Hello friends, you are watching channel number Collage. This is my sincere effort to help you understand basic mathematics in a simple and easy manner. In this video, we will discuss some representative problems based on section formula in vectors. Suppose point R lies on segment AB and divides segment AB internally in the ratio 1:3. We have to find the coordinates of point R, x, y, and z. From the coordinates of these 3 points, we will write their position vectors. So, position vector of A will be from the coordinates, that of R will be from these coordinates, and of B will be from these coordinates. Now, in order to find R bar, we will use section formula for internal division, which goes like this: R bar equals MB bar plus NA bar divided by M plus N. Now, working crosswards, we write from 1 to B bar and from 3 to A bar, and write R bar equals 1 B bar plus 3 A bar divided by 4. This will be 3 2s are 6 I, 3 into minus 6, that is minus 18j, and 3 into 8, that is 24k. Now minus I plus 6i will be 5i, 3j minus 18j will be minus 15j, minus 4k plus 24k will be plus 20k divided by 4, which will be 5 by 4 I minus 15 by 4 j plus 20 by 4 k, which finally will be R bar equals 5 by 4 I minus 15 by 4 j plus 5 k. So from this position vector, we get the coordinates of this point R, which will be 5 by 4 minus 15 by 4 and 5. Now what if point R lies on segment AB and divides segment AB externally in the ratio 1:3? We have to find the coordinates of point R, x, y, z. From the coordinates of these 3 points, we will write their position vectors. Therefore, position vector of A will be from these coordinates, that of B will be from these coordinates, and that of R will be from these coordinates. Now, in order to find R bar, we will use section formula for external division, which goes like this: R bar equals MB bar minus NA bar divided by M minus N. Please note the use of minus sign here. Now we will work crosswords as usual from 1 to B bar and from 3 to A bar, and write 1 times B bar minus 3 times A bar divided by 1 minus 3, that will be minus 2. Minus 3 multiplied by 2 will be minus 6. Minus 3 multiplied by minus 6 will be 18, and minus 3 multiplied by 8 will be minus 24. Minus I minus 6i will be minus 7i, 3j plus 18j will be 21j, minus 4k minus 24k will be minus 28k divided by minus 2. This gives us 7 by 2i minus 21 by 2j plus 28 by 2k, which finally gives r bar equals 7 by 2i cap minus 21 by 2j cap plus 14k cap. Now this position vector of point r gives us the coordinates of point r, which will be r 7 by 2 minus 21 by 2 14. If a bar, b bar, c bar are position vectors of point a, b and c, and it is given that 5a bar minus 3b bar minus 2c bar equals a zero vector, then we have to find the ratio in which point C divides segment BA. We are given 5a bar minus 3b bar minus 2c bar equals a zero vector. So we write 2c bar equals 5a bar minus 3b bar. That will be c bar equals 5a bar minus 3b bar divided by 2. Now we will express these two in terms of this 5 and this 3 and write c bar as 5a bar minus 3b bar divided by 5 minus 3, which is this 2. Now since there are negative signs in both numerator and denominator, it suggests that point C divides segment BA externally in the ratio 5:3. Now the figure changes and C is shown outside of BA, and here C divides segment BA externally in the ratio 5:3. If 3 points A 3 2 P, B Q 8 minus 10 and C minus 2 minus 3 1 are collinear points, we have to find the ratio in which point C divides segment BA. We also have to find the values of P and Q. Now from the coordinates of these 3 points, we will write their position vectors. So position vector of point A will be from these coordinates, that of B will be from these coordinates, and C will be from these coordinates. Now let point C divides segment BA in the ratio lambda as to 1. So we will use section formula for internal division and write C bar equals lambda A bar plus 1 B bar upon lambda plus 1. We will write C bar A bar here and B bar here. After that we will cross multiply these two. Now we will collect the coefficients of I, J, K from both left hand side and right hand side and write them together. So it will be minus 2 times lambda plus 1 I minus 3 times lambda plus 1 J and lambda plus 1 times K, which will be equal to lambda q plus 3 times I, 8 lambda plus 2 times j, and minus 10 lambda plus p times k. Now, according to equality of vectors, we will write minus 2 times lambda plus 1, which is this, equal to lambda q plus 3, and this will be our first equation. Then minus 3 times lambda plus 1 equals 8 lambda plus 2. This will be our second equation, and lambda plus 1 equals minus 10 lambda plus p. This will be our third equation. Now we have to solve these equations in order to find first the value of lambda and then value of p and q. Let us see how. We have the diagram here and we write the three equations which we have just got. The second equation contains only one variable lambda, so we will solve it first. So it will be 8 lambda plus 3 lambda equals minus 3 minus 2, which will be minus 5. So 11 lambda is minus 5, so lambda will be minus 5 by 11. Here the negative sign suggests that point C divides segment AB externally in the ratio 5:11, which is our answer. Now we will change the diagram and draw it again. Here we find that point C is outside of segment AB because it divides segment AB externally. That is, AC divided by CB is 5:11. So this is our answer. We have shown the diagram for reference. We have lambda equals minus 5 by 11 and the two remaining equation, equation number 1 and equation number 3. By putting the value of lambda in equation 3, we will find the value of p. So in place of lambda we put minus 5 by 11 and here also minus 5 by 11. It will be 6 by 11 equals 50 by 11 plus p. So p will be 6 by 11 minus 50 by 11, which will be minus 44 by 11, and this gives p equals minus 4, which is our first answer, the value of p. Now we will substitute the value of lambda in equation number 1 in order to find the value of q. So in place of lambda we put minus 5 by 11 and in place of lambda here we put minus 5 by 11. The bracket gives 6 by 11. It will be minus 12 by 11. So 5 by 11 q will be 12 by 11 plus 3. It will be 45 by 11. This 11 cancels with this 11. So q will be 45 divided by 5, that is 9. So the value of q is 9, which is our second answer. If A 5:1p, B 1qp and C 1 minus 2 3 are the vertices of this triangle, and G R minus 4 by 3 minus 1 by 3 is the centroid of this triangle. We know that centroid is the point of intersection of the three medians of a triangle. We have to find the values of P, Q and R. From the coordinates of the vertices and that of the centroid, we will first write their position vectors. So position vector of point A will be this from these coordinates, of B will be this from these coordinates, and of C will be this from these coordinates, and of G will be this from these coordinates. Now we have the centroid formula G bar equals A bar plus B bar plus C bar upon 3. We will put the vectors G bar, A bar, B bar and C bar and write this is G bar, this is A bar, this is B bar, this is C bar. We will cross multiply this and write 3 times this is G bar, A bar plus B bar plus C bar. We have given this figure for reference. After cross multiplication we write this. This will be 3R, this 3 cancels with this 3, it will be minus 4J, this 3 cancels with this 3 and leaves 1 only. Then 5 plus 1 6, 6 plus 1 7I, then 1 plus Q minus 2, so that will be Q minus 1J, and P plus P, that is 2P, 2P plus 3, so 2P plus 3K. Now by the property of equality of vectors, we write 3R equals 7. So that gives us R equals 7 by 3. So the value of R is 7 by 3. This Q minus 1 will be minus 4. So that gives us Q equals 1 minus 4, that is minus 3, and Q will be minus 3. So here this Q will be minus 3. Finally we have 2P plus 3 equals 1. So that is P will be minus 1. So the value of P will be minus 1. So these are some representative problems based on section formula in vectors. If you like this video, subscribe this channel to get more videos of this type. Share this video with your friends and relatives. Thanks for watching. See you in the next video. Keep watching Number Collage. Thank you.